So 1.4, solve linear equations with variables on both sides of the equation. Shouldn't matter, you guys. We can still isolate those. And remember, that process is pretty consistent no matter where the variables are, or if they're on the left side and right side, doesn't matter. If you'll distribute first, combine like terms, isolate your x's, and then divide by the coefficient, you'll solve any linear equation pretty quick. So again, I can't stress this enough, because a solution will always make an equation true. Now in the future, when we see some different types of equations, we have to go in and test to make sure it gives us a true statement. Otherwise, we may have put too many answers in. We don't need to worry about that too much with linear expressions or equations, though. And yeah, principles of equality. Again, whatever you do to one side of the equal sign, you need to do it to the other side of the equal sign. But again, also the manipulating thing. Just like we saw in that last section, we're manipulating things all the time, right? Whether it's with distribution, whether it's combining like terms, or isolation of variables, which we use the principles of equality to do. But all of that is manipulation of things, and it's not random, you guys. Like it's focused, it's forced. We're putting it in there because we know what we want out of the equations, right? We want it to be like x equals something, or the variable, just one of them to equal something. So this is a good problem. It's coming up. 17x equals negative 11x. Now there's no distribution on this, and in fact, again, with combining like terms, we've got to look on only one side of the equal sign at a time. We have like terms, they're just on opposite sides of the equal sign, so I can't combine them directly. Well, this brings up a predicament, and we may just need to think about this a little bit, okay? And we want to isolate the x's, the variable. I just don't know which side you guys want the x's on, okay? Left first, though, okay? So I'm going to put it on the left. But again, it doesn't matter which side you put it on, okay? So I'm going to write this out even, right? I want my x's on the left. I want my numbers on the right. Now, just for you guys that don't know, that's not a hashtag sign for my generation. That was a number symbol, okay? So that's a number symbol. I want all my numbers on the right. Well, most students will put it on the left side. And that's almost purely out of habit, but there are some cases where students will be like, I know I need it on the right side, and that's almost always specifically because they want positive coefficients. And you can force that if you'd like. And again, that's the nice thing about the manipulation. You're good as long as you maintain the equality of it, okay? So right now, I've got that negative 11x is on the number side of things, but it has an x. I'm telling you guys, it is coming. There is a time coming where you will want positive coefficients, but that's not until the next unit 2. So you can keep your coefficients negative for now if you'd like. You can keep all of your x's on the left or the right. Again, it's not going to matter. Now that negative 11x, it has an x. It's on the number side. I need to zero it out because it's on the wrong side. How do I zero out a negative 11x? Well, again, it's just a matter of adding its opposite, so that'd be plus 11x, right? But again, and yes, I am purposely manipulating this to be a 0, right? On the right side of that equal sign. But if I do it to the right side of the equal sign, I got to do it to the left side as well. So 17x plus 11x, that's going to give me 28x. Right there. But I don't want 28x's. What I would really like is 1x. And how do I make a 28 a 1? Just divide it by itself. Now, this is going to be real nice because 0 divided by anything is still 0, which means x is 0, you guys. And this one's pretty easy because anything multiplied by 0 is also 0. So when I check this and I say, well, 17 times 0, that's 0. And negative 11 times 0 is 0. And we already know that 0 equals 0 is a true statement. So this is the correct answer. This value of x is a solution because it makes the original equation a true statement. All right, 4x minus x. I'm sorry, 4x equals x minus 18. So again, this is the first time we see x's on both sides. It's a short problem though. And again, it's really just is a matter of, well, which side do you guys want the x's on? And for the most part, students do want the x's on the left side of the equal sign, which means we should get numbers on the right side of the equal sign right there, okay? Now, if I were just to analyze this in the beginning, I got a 4x on the left. That's on the correct side of the equal sign. And then we got the x. It's on the incorrect side of the equal sign. And the negative 18 is just a number by itself. It's a constant. So that is on the correct side of the equal sign. So I need to focus on that x right there. I need to zero it out because it's on the wrong side. So that's a, again, if you want to see that as a 1x because its coefficient is 1, then we got to take that 1x and actually subtract the 1x right there, okay? So I've got that 1x minus 1x, and again, if you do it to one side, you got to do it the other side as well. But it does accomplish what we were setting out to do on that by manipulating this so that there were no x's on the right side of this equal sign. So I got 4x minus 1x, which is now going to be 3x. And this is going to equal, I'll just drop that negative 18 right there. But don't forget the negative on that 18 because, again, it's a negative 18 term. It takes the operation to its left as its sign as addition or subtraction, okay? So now we got a one-step equation. That's pretty nice. Just divide both sides by the coefficient to make 1x, and 1x now equals negative 6. But again, I'm going to use my calculator just to go back and check. 4 times negative 6 is negative 24. That's pretty good. But what about negative 6 minus 18? What does that equal? Bam, negative 24. So that's a good answer right there. So we confirmed that negative 6 is the solution to this equation because it makes the statement true. So here's the next one. 7x plus 8 equals negative 7x plus 7. So process is the same. You know, I should be looking for distribution first and combining like terms, but there is nothing to combine for like terms on either side of this equal sign. They're on different sides. So I need to apply the principles of equality to manipulate this until the x's are where I want them and then the numbers are where I want them. Now, I've been putting x on the left side. I'm just going to put it on the right side for this one. I'm going to put all my x's on the right side just to show you guys that it can be done. And it doesn't change the answer or the correctness of the answer as long as we check it, right? So I'm going to put numbers, all my numbers on the left side of the equal sign or that green line there. Which means, just going back to analyzing this, that this 7x right here is on the wrong side of the equal sign. Now, there are other terms that are on the wrong side of the equal sign, but I'm going to focus on the 7x first because it's the first one I encounter. So I'm going to zero it out by subtracting it from itself. We're just adding its opposite. You could say that's plus negative 7x, and that would work. But if I do it to one side of the equal sign, I got to do the other side. So that does zero out, which is what I wanted, and I'm left with this 8 right here. Now equals negative 7x minus 7x, which is negative 14x. And then I'll drop this other 7 right here, and that's a positive 7. So continuing to analyze this, I got an 8, which is a number on the left side of the equal sign. And I got negative 14x, which is on the x side of the number of the equal sign, which is on the right. But this positive 7 does not have an x, so it's on the incorrect side of the equal sign. So I'm going to zero that out by subtracting it from itself there, or adding its opposite. And that does zero out, so I got 8 minus 7, which is 1. And it equals negative 14x now, so I'll just drop. And yeah, I don't need to worry about that 0 because it's gone. I just made it a phantom 0. But I don't want negative 14x's, I want 1x, so I'm going to divide both sides by negative 14 to make that 1x. And 1x now equals, well, we'll show it as negative 1 over 14 like this. So that's pretty good, and that feels pretty good, you know. That was a lot of work, but again, I can check this. 7 times negative 1 over 14 plus 8 equals 15 over 2. Now I'll do negative 7 times negative 1 over 14, but this is plus 7, right? And yeah, sure enough, it's 15 over 2 on my calculator, and I can feel pretty good about putting this answer in. On this, Again, I'm just looking by process. I mean, I'm going to look at this and see if there's any distribution. There is none. Now I'm going to look for any like terms to combine, and there is like terms that I can combine on this. Right, I got this negative 4x and the negative 7x, which would combine to give us negative 11x's. But also this negative 1 and negative 3 are like terms, and I can combine those to make negative 4. Yeah, then equal right here. And now I'm on the right side of that equal sign, and sure enough, there's x's that I can combine. That's a negative 9x and a positive 1x, which would combine to give us negative 8x's. And then, of course, that minus 6 right there. Just drop it. It had no other like terms to combine with. So now I'm looking at an equation now that slightly resembles the equation that we just solved. So we'll start manipulating this. We'll go back to putting the x's on the left and numbers on the right. So the negative 11x is in the correct place, but that negative 4 needs to be zeroed out because it's in the wrong side of the equal sign. So I'm going to add 4 to it, but if I do it to one side, got to do it to the other side. That's zeroed out though. So I'll drop this negative 11x now, and it equals, I'll drop this negative 8x. And negative 6 plus 4 is negative 2. Well, now I've got a negative 8x on the wrong side of that equal sign, so I got to get rid of it by adding its opposite, so add positive 8x. But once again, to both sides of the equal sign. And that does zero out right there, which is just exactly what we wanted. So we're manipulating it, and it's looking pretty good. Negative 11x plus 8x would be negative 3x. And this now equals, again, don't drop this as a positive 2. It's negative 2, you guys, because that was a minus 2, making the term itself negative. Finally, we'll make the coefficient of x a 1 by dividing it by the coefficient by itself, but on both sides. So now that's a 1x. 1x now equals, okay, that's an x. Negative 2 over negative 3 is just 2/3. Positive, by the way, because a negative divided by negative is positive, whereas I prefer to think about it as there being two negatives. Well, let's go ahead and check it. So the left side, after evaluating it, gives me negative 34/3. And then on the right side, negative 9 times 2/3 plus 2/3 minus 6 is negative 34/3. So it shows that it does give us equality. And so I know that this is the solution to this, well, slightly large equation. All right, here we go. Finally, some distribution. So on this one, we'll start with some distribution, like we should, and we should always be looking for distribution first, even though it may not be necessary because there's not parentheses and all these problems. So I'm distributing first the 8, because I'm starting on the left. Again, that's just me. You can start on the right if you'd like. But I'm distributing this 8 into this parentheses, and of course we start with 8 times the x, which is just 8x. But then also we've got 8 times, I'm going to show that as negative 4, which is negative 32. Now we got that negative 6x. I'm just going to keep it where it is, and some of you guys would already start combining like terms, and you can if you'd like. Just be careful that you don't get things mixed up. All right. Next up, I got this negative 6 that I got to distribute into the set of parentheses. So I'll start with negative 6 times x, which is just negative 6x, negative 6 groups of x. And then we also have negative 6 groups of 6, which would give us negative 36. And then finally the minus 4. So the distribution is taken care of. Now I look to combine any like terms with addition or subtraction on either side of the equal sign. And I start with my x's right there because I got those 8x's, and I see I got that negative 6x that I can combine it with, and it gives us 2x's. I can drop that negative 32 because there's no other like terms on the left side of the equal sign to combine it with. And I can drop this negative 6x because there's no other like terms with to combine it with. But I can combine the negative 36 and negative 4 to make negative 40. So we've simplified this pretty good, but of course it's not finished. And we'll go back to the usual, and most students prefer that the x's are on the left, numbers on the right. And we got the 2x. It's on the correct side, but the negative 32 is on the incorrect side of the equal sign, so I'm going to zero it out by adding its opposite. So add 32 there. But I got to do it to both sides. So that zeroes out, and I've got the 2x there, which I can drop, 2x. And I got the negative 6x, which I can also drop. But negative 40 plus 32 is going to give me negative 8. Well, now we've got that negative 6x on the wrong side of the equal sign. Let's change it. Let's manipulate it into a 0 just by adding its opposite. But if I do it to one side of the equal sign, I got to do it to the other side. So that zeroes out, which is good. That's what we wanted. 2x plus 6x is 8x, which now equals, again, don't forget to drop this as a negative 8, not just 8. And then finally, a one-step equation. I'll divide both sides by the coefficient of x, which in this case is 8, to make that 1x. So now x equals negative 1. But I am going to check this even though it's kind of long, right? So I got 8 parentheses, negative 1 minus 4, close parentheses, minus 6 times negative 1 equals, my calculator shows negative 34. So whatever I put in on the right side of the equal sign should give me also negative 34, but let's check. Negative 6, open parentheses, negative 1 plus 6, close parentheses, minus 4 equals negative 34. So we did that really good. That came out exactly like we wanted it. It is a solution because it makes the original equation a true statement. All right, so this is all very mathematical. It's very algebraic, almost slightly abstract. But if you can get used to that manipulation of equations and math expressions, things, if I haven't told you guys this yet, you can do anything in math if you can just learn how to manipulate things properly. And that's what the properties of equality do, or principles of equality, whatever you want to call them. But I also use what I call the switch and stay game, and I use it particularly on really large problems. Now, we haven't seen anything super large, but some students would look at this and they'd say, yeah, that is pretty big right there. Right? It's like, well, it's just long, really. But this is the way that the switch and stay game works, and it's not required that you use any one method. I just want to make that clear, because some students like to draw pictures, actually, of this kind of stuff. And you can model it with pictures. Not very many students do, but you're welcome to if you'd like, all right? But in any case, there's 7 steps to the switch and stay game, which you can see right there, right? So it says to distribute, but this one doesn't have any distribution in it, so I don't really need that. Next up, we'll draw a line through the equal sign, just like it says, like this. Well, I'm going to make this one a little bit longer. Yeah, what the heck? We'll make it really long. So this one has no distribution. Line through the equal sign. Now choose a side for the unknown, which is just the variable. I'll choose it on the left, just because we kind of have a pattern of doing that. It's not required, though. You get to choose which side you want it on. Play the switch and stay game. So this is what I'm going to do. I'm going to go from left to right through all the terms. Now, the thing about the switch and stay game is that any term that crosses that blue line that I've drawn, I have to change its sign, which creates kind of a little bit of a rhyme, right? If it crosses the line, then you change the sign. Yeah, that seems to rhyme pretty good. So I'm going to start with that 2x right here. Bam, right there, right? So it's a 2x, so it goes on the left side of the equal sign of that blue line. So it just stays positive 2x, done, so I can cross it out. But this negative 37 is going to cross the line, which is going to now make it a positive 37. I should probably use a thinner pen on this. So I used it. It's goner. Next up, 43x stays positive 43x. Switch or stay, right? So it stays positive 43x. The negative 28, though, it's going to need to cross that blue line. If you guys are hating this already, you don't need to worry. You don't have to use this method. But that negative 28 is going to cross the line, so I'm going to change its sign into a positive 28. So it's switched. And then the negative 13x is going to stay negative 13x. Bam, there we go. Next up, this 90 is going to stay, because now I'm on the right side of that line, which is the number side. So it stays positive 90. But this positive 27x is going to switch to a negative 27x. So it goes away. Negative 61 is going to stay negative 61. And then positive 17x is going to switch to negative 17x. So I used it up. And then negative 5 is going to stay negative 5. And this negative 3x is going to switch. It's going to cross the line, so I'm going to change that sign into a positive 3x. And then finally 208 stays positive 208. That is the switch and stay game. Dude, look how fun that was. Like, some of you guys enjoyed it so much, you want to make up your own problem and do it. Well, we'll give you another chance at it. You don't have to, though. So, again, if you're still hating this, don't worry about it. It's just a nice algorithm. It's a nice process to solve really large equations like the ones we're looking at. Okay, I use the 208. Now, I've got my x's on the left side of the equal sign, and they're going to stay there. So I got my x's, right? So it says next to add and subtract. It's just adding and subtracting all these like terms. We've put these like terms in a nice order. We've almost categorized them, right? And now we're ready to add all the coefficients and like terms. So 2x's plus 43x's minus 13x's minus 27x's minus 17x's plus 3x's. You know, I'm going to go to my calculator for that. I'm just going to type in 2 plus 43 minus 13 minus 27 minus 17 plus 3. Give me a negative 9x, you guys. And then I'm going to add all the numbers on the right side there. So 37 plus 28 plus 90 minus 61 minus 5 plus 208. Just using a calculator, this gives me 297. Right there like that. So by adding and subtracting right there, we just pretty much made a one-step equation, which should make this pretty easy from here, because all I got to do now is divide both sides by the coefficient of x, which is negative 9. So finally, 297 divided by negative 9 right here in my calculator, that tells me that x equals negative 33. And yeah, we can type this in just to check it. So yeah, both sides now give us negative 1,121, which is what we wanted. But yeah, I had to check. Now, notice, you guys, when I typed it into the calculator, I found that there was an error, but I feel good about the work that we did. So just going back, I just saw that I typed it in incorrect in the calculator. That's a crucial, and a lot of students may get discouraged by that, especially when you're doing a problem that's kind of long like this one. But please don't get discouraged. You know, I mean, it may take a little bit of extra time and analysis to try to figure out where a mistake was made, but we figured it out, and we know now that the final answer to this one actually is x equals negative 33, which would make it a true statement.